Data evolves. New requirements emerge and schemas need to adapt. But how do you manage these changes without breaking everything downstream? That's where version management in schema registries comes in. Let's dive into how this works and why it's vital for robust data ecosystems. Think of schema versions as snapshots of your data structure at specific points in time. Every version represents a specific configuration, allowing teams to track changes and manage updates. For instance, when your organization decides to add new fields or modify data types, a new schema version is created. This historical tracking ensures you can trace back and understand why certain data transformations were made, while also supporting legacy applications. Effective versioning is like maintaining a solid foundation for a house while adding new floors. This is done using semantic versioning. Major versions. These signify breaking changes. For instance, moving from customer.v1 to customer.v2 could introduce a completely new structure or remove existing fields, requiring applications to adjust accordingly. Minor versions, these represent compatible updates. Changes like adding a new optional field, v1.1 to v1.2, don't disrupt current operations. This strategy ensures that updates are predictable and compatible with various parts of your data infrastructure. Here's where schema registries truly shine. The registry keeps all versions, allowing teams to fetch specific versions for legacy compatibility, always access the latest version for modern applications. This ensures that different systems consuming the same schema can continue to operate smoothly, minimizing disruptions. Think of it as being able to choose between driving the latest car model or sticking to a classic. It all depends on what your application needs. Version management in schema registries provides a structured way to evolve your data while keeping systems aligned and operational. Whether it's breaking changes or seamless updates, you're always in control. Welcome to the new era of video creation with Jog AI. Simply type your script to get started. Let's face it, data is dynamic. As business requirements change and new technologies emerge, schemas must evolve to keep up. This process, called schema evolution, is a critical component in maintaining the relevance and usefulness of your data contracts. Imagine your data is like a bridge connecting your business and your users. Over time, that bridge needs upgrades to handle more traffic or accommodate new types of vehicles. Adapting to consumer needs. Schema evolution ensures your data stays aligned with the changing requirements of data consumers. This keeps the data fresh, relevant, and practical for business needs. Enhancing service features. Updating schemas enables the introduction of new functionalities and improvements, driving better performance and enriching user experience. So how do you actually handle schema changes without causing chaos? Two key strategies come into play. Migration planning. This is like building a detour before upgrading a highway. A well-thought-out plan ensures consumers transition smoothly to the new schema version. The level of complexity depends on the scale of changes and the number of stakeholders involved. Version management. Sometimes you might run both old and new schemas in parallel for a limited period. For smaller updates, this minimizes disruption, but for significant changes, you'll need robust tools and libraries to help consumers adopt the new schema seamlessly. Schema evolution is not just a technical exercise, it's a strategy for future-proofing your data. By adapting to evolving needs and planning migrations carefully, you ensure that your data continues to drive value. All right, let's dive into a topic that keeps your data systems running smoothly, non-breaking changes. Think of these as minor updates to your house, like painting a wall or adding a shelf, that don't disrupt your day-to-day life. In the world of data schemas, these changes are a game changer. Non-breaking changes are like gentle upgrades to your schema. They are modifications that ensure compatibility with existing systems and prevent any disruption for current data consumers. They allow backward compatibility, meaning data consumers using previous schema versions can still work seamlessly without any hiccups. No data loss, no panic, just smooth operations. Wondering what this looks like in practice? Here are two great examples. Adding optional fields. Let's say you're adding an address field to a customer schema. Consumers who don't use this field won't be affected, and those who need it can start leveraging it. Removing non-required fields. Suppose you decide to remove a non-mandatory field with a default value. Since it wasn't critical, existing consumers won't even notice. The best part? Non-breaking changes have a low impact on data consumers. They don't need to scramble to update their systems. They can continue as usual while the schema evolves. This fosters smoother transitions and encourages faster adoption of new features without unnecessary stress. Non-breaking changes make schema evolution a breeze. They ensure flexibility, maintain stability, and minimize disruptions for everyone involved. It's a win-win. Let's talk about non-breaking changes. Think of these as software updates that don't interrupt your work, a smooth, seamless transition that lets you keep using the system while enjoying improvements. Non-breaking changes are a key concept in maintaining data compatibility while evolving your schemas. Non-breaking changes are schema modifications that don't disrupt existing data consumers. These changes are backward compatible, meaning data produced with the new schema can still be understood by applications using older schema versions. It's like upgrading your phone. Your favorite apps still work the same. Here's how this plays out. Adding optional fields. Imagine adding a field called address to a customer schema. Existing users can safely ignore it, while new systems can start utilizing it.